So before we get started, how many have heard about Microsoft Fabric? Just by show of hands. Wow, perfect. How many of you are data analysts? Data analysts? Perfect. On that category of data analysts, how many of the data analysts are super scared of data engineering? Come on, it's something I've heard from many data scientists, data analysts, like, I just want Power BI, nothing else, right? And one of the things we're trying to do with Fabric is trying to bridge the gaps and break down the silos, because traditionally a data analyst is a data analyst. They live and breathe Power BI, Tableau, and all the other analysis tools. Data engineers, again, Python, Spark, Lakehouse, things of that nature, and they all live in these kind of silos. And what you're trying to do is break down the silos, make it easy for a data analyst sometimes to understand what is going on with folks over at data engineering. So basically we'll try to explore that in depth, but I'm going to use this credit card demo. I really wanted to do an actual demo, but time might not allow us to. But I'll provide you with all the source code, and you can be able to actually build on top of all of this. Right, the last question, how many of us are data engineers? Data engineers? Good, all right. That's me. You can follow me on LinkedIn. That's my LinkedIn, and the bottom one is on for Twitter. Okay. Okay. So yeah, top one is LinkedIn, bottom one is Twitter. Yeah, sure. All right. So this is what we're going to cover. We're going to do a brief and quick introduction to Microsoft Fabric, and then we'll explore the solution of building a credit card fraud detection system. We'll see how the various ways we can be able to bring in data into Microsoft Fabric. We'll explore how we perform feature engineering using the data engineering workloads in Microsoft Fabric. We'll cover ML and how we also handle real-time analytics. If time allows, we'll cover real-time analytics part. If time doesn't, we'll just skip right all the way to the Q&A. How I like doing my workshops, my style is ask me a question as we proceed. Don't have to wait until the end. So at any one point, if you have a question, just shoot your hand. Hopefully there won't be too many. But yeah, I prefer answering questions as we go, as we progress. All right. So we good to start? Because of time, I might rush through a lot of the few things that I have, but we'll see what we are able to cover in the 45 minutes allocated. Right, introduction to Microsoft Fabric. Now, when you've following very many conversations across the years, we've had a lot of feedback from most of the customers who've been trying to lead these data-first modernization, and a lot of the challenges they are facing is, one, as I mentioned, most of the data professionals exist in silos, right? So that's one of the challenges. Another great challenge that is there is, I've mentioned about the silos that actually exist in many of these data organizations. And the other thing is talking about governance. You have this wide range of data estate. Data is fragmented. I'll be showing you that in the next slide. And again, being able to apply governance across your data estate, that also is becoming a challenge for many of the organization, and also talking about the promise of real-time analytics, how you're handling also real-time data. So whenever you're thinking of your data estate, you're thinking of maybe you have data at rest. This could be structured and unstructured data. You also could be dealing with also real-time data that is probably augmenting your data at rest, and also how you actually manage all of that. And also, when you think of most of the data solutions in many organizations, something looks something close to that. What that means is you have different solutions and services for your infrastructure, for your integration, for ML and AI, for storage. It's pretty fragmented, and you'll find most of the organizations, when they're trying to build an enterprise-wide data analytics solution, they're faced with this challenge. Some of the data is seated, in some cases, in a different cloud provider, in a different services. So think of it like this. It's spread out across different service providers, and among those service providers, it's spread out among different products. To make matters worse, each of these different products might be using a proprietary format that, in case I need to move my data into another product, into another service, I have to do some transformations for it to be able to work in the other product. So these are kind of the challenges that exist in the modern tech stack, in the modern data tech stack. So there is a massive fragmentation across services and across products. And now that's where Microsoft Fabric comes in. Microsoft Fabric is a unified analytics platform, or a unified analytics solution in the era of AI. What that does, we try to break down the silos, number one. We also try to reduce the massive fragmentation of your data. And we do this using the following 7 workloads. So, 6 workloads from Data Factory all the way to Power BI. And I'll just talk briefly about all of them, and then you can be able to see how everything ties together. So, when you think of Microsoft Fabric, I mentioned it's unified analytics. So what that means, all the different personas that are working with data in your organization can comfortably use this platform and be able to perform all their tasks, all their workloads from a single point of truth. So when you think of data engineers, they need to build their pipelines. How are we bringing in data That's where we have Data Factory. Yeah, that's where we have Data Factory, which allows you to be able to create the different pipelines for you to ingest data. And as we'll see, as we progress, scientists also, they have their own. They can be able to access all of these their different workloads directly from within Fabric, and we also have real-time analytics and Power BI for your business intelligence as well. Now, the most important thing, you can be able to see all of these different personas, from a data engineer, data analyst, data scientist, all of them, they're able to work from a single point of truth. What that means is, I might have a data engineer who has worked on their data, they've been able to perform some different transformations, and that data can be picked up by the data scientist without any further transformation required. And here is why. Remember when I was talking about the massive fragmentation and different products having different proprietary formats in terms of the way they store data? When on Microsoft Fabric, we use an open format called Delta Lake. So all our files inside Fabric, we store them in the format of Delta Lake. So if maybe out there you already have your data also in Delta Lake, no further transformation is required, and you can be able to directly start leveraging the product. So what that means is you're not locked to the product, because we are using an open format that is supported by the wider data community. So as I mentioned, there are 6 key workloads. I've already mentioned about the Data Factory one that allows you, it's going to combine the power of Power Query and also Data Factory. So if you've worked with Power BI, you already are well conversant with Power Query. Data Factory will also help you to build your pipelines, and we have over 200 native connectors that can be able to connect to wherever your data is seated, whether it's on-prem or on the cloud. Also for the data engineering workloads, we have the Spark platform that allows for you to, that allows data engineers to transform data at scale. We also have the warehouse, that's the SQL data warehouse as well. So this also provides SQL performance at scale. So you can be able to store, you can be able to scale, and also it stores data using the open Delta Lake format. We also have the data science workloads. This allows you to build and also deploy and operationalize machine learning models. So you can be able directly within Fabric, you can be able to actually build your ML models and also perform your different data science and operations directly from the same tool. The same with the real-time analytics workload for handling your real-time data, and also we have definitely Power BI that is also baked in within Microsoft Fabric. Now, the most important thing, traditionally, when you had to deploy your kind of end-to-end analytics solution, you had to think like, I need to provision compute, I need to provision storage, and I also need to manage and maintain all of that myself. So I need to handle how it scales up, how it scales down. All of that was what I had to do it myself. But with Fabric, it's a SaaS solution. So what that means is, once you deploy, or rather, once you have access to Microsoft Fabric, you don't need to worry about all of that. You know, it's a SaaS platform, and so if maybe the data scientists are using more workload, it uses a serverless compute, so it's going to allocate compute accordingly depending on which workload needs what compute. So basically, that's it about Microsoft Fabric. It's a unified analytics platform. We're trying to break down the silos across all of these different personas within your data organization. So far up to that point, any question? All right. So we'll move forward to solution architecture. Oh, and just before I leave there, if you really want to get started today, right now with Fabric, it's in private preview, so you can be able to try it for free. Just go to aka.ms/try-fabric. aka.ms/try-fabric, and that should be able to get you started. Now, let's get into the actual architecture for our credit card fraud detection system. So, a credit card fraud detection system, I'll just call it an FDS, is typically composed of 5 major layers. All right. So the first layer is a terminal layer. We also have a transaction and blocking rules layer. We have a scoring rules layer, a data-driven layer, and also a layer for the investigators. Let's start with the 2 first layers. You know, the terminal layer and the transaction blocking rules layer. Now, in the first layer, the terminal layer, these ones are actually executed in real time. They have to happen in real time. And so what that happens is, at the terminal layer, we have security checks for the incoming transaction attempt. So here, that's where we are checking for things like, is it the correct PIN? Do you have sufficient balance? Is your account active? You know, those have to happen in real time. If it's the wrong PIN, the transaction should not be authorized. The same if you have insufficient balance and also an inactive account. All of that happen at the terminal layer. So any of the attempt that doesn't meet the criteria specified in the terminal layer automatically goes through the transaction blocking rules layer. And now at the transaction blocking rules layer, you'll notice we have different shadings on the different layers. And this one is an expert-driven layer. And what that means is we have a set of rules that are specified in the transaction layer that are specified by the domain experts. And so what that happens, these are just like if else or if and then kind of rules. And so these might include something like if the transaction is happening, if it's an internet transaction and it's coming from an insecure and the connection is insecure, do not allow the transaction to go through. So these are based on the domain expertise in terms of how fraud happens. They set up these rules. So this is really dependent on the domain experts and the kind of rules that they actually use. The same way with the scoring rules layer, it's also an expert-driven layer as well. So at the scoring rules, this is also based on expert. This is also based on expert knowledge, and what happens here is depending on a particular set of rules that they have actually set. Like for example, if you might have a scoring criteria of something like a transaction happens in 2 different continents in a period of this amount of time, and whatever time they specify, and then they can assign maybe score that at 0.95, give it a score of 0.95 as a fraudulent transaction. So again, it's expert driven depending on their domain knowledge on this particular topic. So once it goes through the scoring rules, we also have a data driven model, which is now where data-driven decisions are made. So that's where you can be able to build your ML models for you to be able to determine whether a transaction is fraudulent or not. And the last layer right there is the investigators. This is one that happens offline, where now it's taken up by investigators who are actually the domain experts, and they try to determine whether a transaction is fraudulent, and then they can be able to take the appropriate action, like maybe probably blocking the card. So the first 2 layers, they have to happen in real time, and then the second layer, which is the scoring rules and the data-driven model, those ones happen in near real time, and then the last part, which is the investigators, that also happens offline. And so the data-driven part, that's the part where we model. That's where we actually build. The fraud detection part. Now, just to highlight, this becomes a very complex problem sometimes to try solve it. Here is why, but it's becoming easier with more and more available simulation data. Even the kind of data that we use to train here is a simulated data, because in many cases you wouldn't expect a bank to open source the data of transactions for anyone to kind of train on it. So it becomes pretty hard. But there are tools right now, like one that I'm using, that is able to generate the kind of data, the kind of transaction data that you would expect to have when you're actually dealing with credit card transaction. So that's just one thing to keep in mind whenever you're trying to build this system. It's going to be hard, because if you're not working for a bank and you don't have access to those transaction records, and by no means any bank is going to provide those, it becomes a very, very problematic situation. But there are tools like the ones we use in this workshop, which I'll be sharing a link to, which you can be able to follow along. Now, so as I've mentioned, this is the only part that we focus on, because everything else is left to the domain experts and the financial institutions. Now, how does Microsoft Fabric help you achieve this? All right, if you go back to this architecture diagram, we have an inflow of data. One, we have data at rest, the one that we're using to train our model, right? And we also might be dealing with real-time data that is also handling incoming traffic of the transactions. So just keep in mind, those are the kind of data that we might be dealing with. So one, and I mentioned it's a unified solution. We have from the data integration part with Data Factory, you have your integration in terms of you specify you're bringing in this data directly into your workspace. So this data could be seated somewhere outside Fabric. It might be seated in an Amazon S3 bucket. It might be seated on-prem. Could be seated anywhere, but we can be able to leverage something like the Data Factory to build your pipelines and bring in your data. You have the data engineering workload, that as well, the data engineering workload and the data warehousing workload, that will also allow you to perform feature engineering on your data. So once we bring in the data, remember, before we make it available for data science, we need to do some transformations and also some feature engineering. And so all of that happens in these two phases, and then we go to the data science piece, we build we build, train, and also deploy the ML model, and then we can be able to augment that with real-time analytics. So every time we have real-time analytics coming in, we can be able to determine whether a transaction is fraudulent against the model that we've already deployed from the data science workpiece. And then we also have the Power BI for all your business intelligence, and you can be able to, I think Power BI is almost self-explanatory on that point. Then we have serverless compute, as I mentioned. That's what powers all of these workloads. They are all powered by a serverless compute. And then when I mentioned about OneLake, OneLake is the default storage for Microsoft Fabric. All of us have used or are aware of something like Microsoft Office, right? When you think of Microsoft Office, what's the default storage? What's the default storage? OneDrive, exactly. The same way if you were to think of in a Google kind of environment, what will be the default storage or the native storage? Google Drive, right? So in Fabric, our default or our native storage is OneLake. And what that means, the same way if I put everything in OneDrive, I can be able to, like for example, when you're building a PowerPoint and you have other PowerPoints in your OneDrive, you can always be able to add slides into a new PowerPoint from other PowerPoints that are already in OneDrive, right? The same way with OneLake. If a data engineer builds and they transform their data, they store it in OneLake, the data scientists, when they come, they don't need to perform any extra configuration to the storage layer. They can be able to access the data as it is directly from the storage layer, and likewise everyone else. And as I mentioned, we store data in an open format, the Delta Lake, so all of these, they don't have to worry about like, do I need to change into a particular format for me to be able to use this data? They can just be able to access all this data. And again, security, governance, and administration, it's powered. So like if you already have rules within your organization in terms of how you handle PII information, the moment you tag a particular data inside here that this data is, you might have these protection labels, sensitivity labels in terms of this can only be accessed maybe by full-time employees, this can only be accessed by a particular section of the moment you tag that kind of data, regardless of where that data is used, if it's used in a Power BI report, that report as well inherits the same rules, so you don't have to worry much about governance. So again, all of that is already built in. Any questions so far? Sure, let me start there. So whenever you think of a fraud, you're saying where it happens almost instantaneously and it okay, so that happens in these first phases, which might not be in the domain-driven, the data-driven solution we are trying to solve. So the first one, the terminal point, in many cases here, might be a challenge from a user's point. You get the point, because here we are trying to check for the PIN sufficient, the status of an account, that's from you, and then the transaction blocking rules, this also happens in near real time. So these are entirely dependent on on the domain experts and also the financial institutions. And then what we are trying to focus on mainly is this part. So I'm not in the finance business, so I won't claim to have a lot of proficiency in these two parts, but I can talk about the data-driven model part of it. But from the link I provide for the workshop, it's going to also cover. It also covers these first two parts that are done by another individual from my team. Okay. Another question. So what you're talking about is once you finish training your model, like exactly. And I'll cover that on the data science piece, because one of the key features we have in our data science workloads is with the experiments and the monitoring part, where you can be able to track the different versions of your model, and you can go as well performing different iterations of them. So all the ML ops that you can be able to achieve, I'll be able to cover that in the next section, where we talk more in depth about the data science workload. Perfect? All right, so the data integration scenario should look something close to this. So this is the first part, loading data. Seeing time is really running out, so I'm just going to pretty move fast. The data integration part, this is how we bring in data. So we have our structured data. In this case, we're using Packet files. So there are some sort of structured data. So we bring in the structured data using our pipelines built using the data factory. You can also leverage data flow, the data flow Gen 2, especially if you have good experience with data flows. You can be able to leverage the data Gen 2, and then you bring that data into the lakehouse, and that's it. So for your data integration piece, the way we are bringing in data, two important things you need to remember: data factory, data which helps you build your pipelines, and also the data flow Gen 2. You can be able to leverage those two to bring in your data. So as mentioned, the data factory will allow you to do complex ETL scenarios. Yesterday I was somewhere doing a workshop on data factory, and I just showed how you can be able to perform very complex ETL scenarios where your data could be super complex, and you can be able to do that using your pipelines. And the most important thing, it supports over 200 connectors. So most likely, wherever your data is seated, we might be having a connector to bring in your data. In some cases, you might be dealing with data, like for example, in CSV files. So the easiest way to do that is using data flows, especially if you've worked with Power BI. I know this is what did we used to call this in Power BI? Power Query, right? You know Power Query in Power BI? Exactly. So that's what we're using here in Fabric. So again, if you already have some of your data, you can be able to leverage data flow to bring in data into Power BI. So that's the first part of the data integration piece. We leverage data pipelines and data pipelines using Azure Data Factory and data flows as well. So for this particular demo, I'll be sharing the link with you. We leverage the pipelines. So we bring in the data using pipelines directly into the workspace. The next key important thing is feature engineering with Synapse data engineering. So once we bring in this data, we need to perform some particular transactions. One of the key transformations we need to do, we need to kind of first add some features for: did this transaction happen over the weekend? Did this transaction happen over at night? You know, how often? How many transactions have happened? Like, you know, you can be able to create those particular features. So that's the next step for feature engineering, and this becomes our sort of architecture when we are exploring the feature engineering part. So again, the data source. Structured and unstructured. So once we brought in data, definitely now we are working with structured data. You can be able to work with pipelines or shortcuts, or in this case, we don't need this entire ingestion part because we've already covered the ingestion part. But the data is already in the lakehouse. So within data engineering, your key workload or your key important tool in Fabric for data engineer is the lakehouse. And so from the lakehouse, we use notebooks. So the same Jupyter notebooks, right? You've all worked with Jupyter notebooks. Exactly. So the same Jupyter notebooks, you can be able to spin up, you can be able to create a notebook directly there. It has access to Spark. And you'll notice we don't, in the entire notebook, I don't perform a pip install, like to install libraries. Why? You'll find this environment, it's already configured to the needs of you as a data scientist. So whatever you need, it's already pre-installed for you. So you don't need to start worrying about, I need to bring in this library, I need to start worrying about how I'm going to configure my environment. All of that is taken care of you. But in the event you need an extra library, you can always be able to download it or bring it in and perform as the normal pip install as well. But we leverage our notebooks as well to perform the feature engineering. So we're going to do all of that using Python, in this case PySpark. So most of our data frames are in our Spark data frames, because we are handling large data. So all of the feature engineering really happens by the use of the notebooks. And the moment you finish performing your feature engineering, you can see this is a bidirectional arrow here. That means we can be able to read the data we stored in the lakehouse from the previous step into the notebooks, and then once we perform our feature engineering, we can be able to store back the data into the lakehouse for the next steps. Now, just to mention, the lakehouse, what the lakehouse does, it allows you to store, manage, and analyze all your data in a single location. So this is how it looks like. I know it's not very clear, but what happens is you can be able to see all the different tables you've brought in here, and you can be able to open and maybe visualize the data on the right here. And you can, at any one point, you can always right-click and say load to Spark, and it opens that particular table in Spark, and you can be able to start working with that particular data. So, and it's the capability, you don't have to worry, as I mentioned, you don't have to worry about provisioning storage or compute. All of that, again, is automatically handled for you. So for you as a data engineer, the most important work for you is not to manage the infrastructure. The most important work for you is to actually build the solution. So it gives you the ability for you to just jump directly into the platform. As I mentioned, it's powered by the Spark runtime. So you can be able to get started. Immediately you open a notebook, it leverages the Spark compute, and you can be able to actually start building. So the lakehouse is powered by the Spark runtime. Again, I mentioned the notebook. It's the same old notebook that you are aware of. So you can be able to do whatever operations you do in Python for all your data engineering and also data science workloads. All of that is right there. And the most important thing is the capability for you to do collaboration. And if you do live in VS Code, we have a direct button for you to just open for me in VS Code, and I can be able to start working right there. Now, this is the data science scenario. Again, we already have the data that we've performed the feature engineering. It's already stored in Lakehouse and also maybe in the data warehouse. Now, you can be able to create notebooks. You bring in that data. If you need to perform any extra cleaning or any extra preparations, even like splitting into your test train validation sets, you can be able to do that directly using your notebook. And then you can use your, you create your experiments, you train, you deploy your models, and you can also be able to test. Now, here's the most important thing, as I was mentioning. All these are bidirectional arrows. What that means, you can keep on improving and building the different versions for the different models that you're actually deploying. And at the end of that, you can be able to store your model directly into your lakehouse, and you can be able to expose that either onto an endpoint or onto your business intelligence tool. So again, this is the architecture that we have as well for the data science scenarios. So up to that point, I want you to see we've dealt with 3 different personas, each who can be able to work on the same data on the same product without each one of them worrying about, am I dealing with stale data? There are those kind of scenarios where exist. Something was changed by the from the data engineering side, but the data scientist is still working with the raw data. Again, this is the notebook that I had mentioned. You can be able to leverage the notebook for all for your data science workloads, and then with machine learning, it's powered by MLflow, and again, it's built in with all the necessary libraries for you. In this particular demo, we use scikit-learn, and you'll find all of these different libraries. They're already pre-built into the workspace, so you just dive right in there and you start actually building the workloads that you need. Then you can also perform model scoring from within your data science workloads, and you can be able to monitor the performance of your model across, and you can be able to compare across the different versions of the model that you've been able to publish. So normally when I've done this workshop, it's normally a 3-hour workshop, and I spend the first hour of the workshop walking through the architecture. So when I saw 45 minutes, I was like, we can do this in real, actually. But if you go to mo.dev, that's the URL, you'll be able to find the workshop right there, and you can be able to follow along. The workshop is pretty detailed. It really explains each of the steps. It explains exactly what you are trying to achieve. Just go to that URL, and please scan that feedback. Provide us with feedback in regards to Microsoft Fabric. We really, really appreciate your feedback. I'm around in case you need to, I'm worried about Q&A, but I'm around. I'll be just somewhere here. But please, just go to the URL, mo.dev, and you can be able to follow through the workshop. It actually walks through all the steps. You saw the entire pipeline, bringing in the data, feature engineering, data science, publishing, deploying the model, testing the model, and all of that. It's pretty detailed. It's a 3-hour workshop, so I'm sure you will be able to grasp some bits and concepts right there. But I just needed to cover the architecture of how we actually built the solution. Yes, so you browse workshops. It should be inside the workshops, right inside there. If you have any trouble, just see me around here and I should be able to help. But please just fill out the form, provide us with feedback. Anyone else having challenges on the browse workshops? Once you click browse workshops. Anyway, I'll be around, I'll also check out. But this is the link, even if it's not working right now, I'll figure out what's the issue, but you can be able to find the workshop directly from here. And there are also other Fabric workshops directly from there. Yeah? The previous one? If you want to learn Microsoft Fabric, go to aka.ms/learn-fabric. Learn-fabric. ms/learn-fabric. Yes, I'll